Hi gang, this is a review lesson on complex number operations. Part of this video I will have you kind of just work through some stuff on your own and check your work, and some of these videos I will explain thoroughly every example. Well, not every example, but certain examples. So what you need to remember to get started on this is what an imaginary unit is. And so an imaginary number is basically equivalent to the square root of -1. So right here, where it says the square root of -1, that is equivalent to I. And so then I squared, remember, is I times I. Let me just use parentheses. And so that would be the square root of -1 times the square root of -1, which another way to write that is the square root of -1 squared, which is -1. I cubed ends up being I squared times I, and so that is -1 times I, which is -I. I to the fourth, I always usually break it down into I squared. You can break it down a few different ways, but it's I squared times I squared, which is -1 times -1, which is 1. And then I to the seventh, I usually do this. I kind of figure out how many I squareds are in there. And there would be 3 I squareds. I squared times I squared times I squared is I to the 6th, which another way to write that is I to the squared cubed. And then there's an extra I left over. So that ends up being -1 cubed when you substitute -1 in for I squared times I. And so that is -I. Oops, that's not what I meant to write. I meant to write -I. Now, what I want you to do is press pause on this video, and I want you right now to try to do examples 1, 2, and 3. I am going to do them also right now. When you're finished, unpause and you can see if you're correct. One thing I just thought of as I was doing these that's very important is that all complex numbers are written in the form A plus BI. And main thing to know there is A is the real number, just any regular number, and the BI is the imaginary part. Together, those make up a complex number. Okay. Now, just because you probably already are here, take a look at example 1 and 2. Main thing to know about example 1 is that when you have the square root of a negative number, it always breaks into the square root of -1, which is I, times whatever number's underneath. And so in this case, the square root of 9 is 3. You write it in this form right here, 3 plus 3i. Next example, you plug in -1 for I squared. You always have to do that. Never, ever, ever do you leave anything above an I. Like, so you always substitute in -1 for I squared, and then I just simplified there. The next example, you basically are just combining like terms. I kind of distributed the 1, and then -1 through, and then I combined my like terms. What I want you to do now is go to the next page and try example 4, 5, and 6, and then check your work. Okay, if you take a look at example 4, you'll notice what I did is I just did the distributive property. I distributed just like I would if it was two normal binomials with x's. Then I noticed that I had an I squared, so I substituted in -1. That became a -3 times -1, which is a +3. And then I just combined my like terms. Notice I wrote it in the form A plus BI. A big thing about example 5 that a lot of students make a mistake of is that you have to simplify the imaginary part first. So you're going to notice in this first step that I rewrote root -6 as I root 6. And same thing with I root 8. If you don't do that, then you end up, like if you were just to multiply those right away, you would end up losing the imaginary part of it. So that's kind of like just order of operations on how you do that. So then once I got to here, I multiplied together. You multiply outsides and insides, and then I just simplified. So I squared was -1. The square root of 48 I broke into the square root of 16 times 3, and then I just multiplied those all together. Example 6, same thing about simplifying the square root of -2. Notice how I made that into I root 2. And then what I did is I just distributed. Got to be real careful here with everything that's going on. When you take -1 times I root 2, that's negative I root 2. Same thing here. And then I squared root 4. I changed I squared into -1, root 4 into 2, and then just combined all my like terms. But now I want to take a minute to talk about example 7. And you probably remember this from last year, but one of the main things is that in simplifying complex numbers is you can't leave an I in the denominator. That's the same thing as a square root. And usually when we simplify in math, we do not leave square roots in the denominator. So what you have to do is something called rationalize, and what that means is multiply by I over I. And the reason why this works is anything over itself is 1. So we're really just multiplying this original function, or not function, it's not a function, this original expression by 1. Except it doesn't look like a 1, it looks like an I. And so then I'm just going to use backwards distribution here, and I get 5I plus 4I squared all over 3I squared. Now the reason why I didn't use the 3 in the multiplication, because the 3 is fine. The problem is the I. And then what I want to do here is substitute in a -1 every place where I see an I squared, which is there. And then I'm going to simplify 5I minus 4 over -3. And just as a reminder, when you simplify this, I can split this up. 5I over -3 and then -4 over -3. And technically I'm supposed to write this part first. That's the real number. And then here's the imaginary number. Some students leave it like, sorry, my pen's not working. Some students leave it like this. And I'm fine with that too. Either way is fine. But I'm just trying to follow along the lines of A plus BI. Okay, so then if you look at example 8, this one is done kind of similar, except what you need to remember here is these pluses and minuses glue those terms together. So I have the same problem. I can't leave a square root in the denominator, which is that I. So what you have to do here, and I don't know if you remember, but is you multiply by the conjugate. And what the conjugate is in this case, the conjugate of the denominator. It is basically the same exact binomial, but you change the sign. That's the conjugate. So if 3 minus 2i is my expression, 3 plus 2i is its conjugate. But what you have to do is rationalize, which means you multiply it by the same thing on the top and the bottom. And again, remember why we do that. This is equivalent to 1. But this problem's a little bit bigger in the fact that I have a lot of multiplication to do. I have to distribute all of this in the numerator. And I know this kind of looks like a U or something, but it's supposed to be an I. Let me fix it. And then you just multiply. So 6i times 3 is 18i. 6i times 2i is 12i squared. Then I have 1 times 3, which is 3. And then I have 1 times 2i. I'm going to do the same thing with the denominator before I do any sort of simplifying. So then I have 9 plus 6i minus 6i. That's exactly why we multiply by the conjugate, because that equals 0 when you combine like terms. And -4i squared. Now what I'm going to do next is I'm going to simplify the numerator, and then I'm going to simplify the denominator. So I'm going to see if we can kind of do it like this. I know that I squared right here is a -1. So this is a -12 plus 3, which is a -9. And then if I combine 18i and 2i, I get 20i. The denominator, I know that -1 is equivalent to I squared, so this becomes a plus 4. And so then I'm basically taking the 9 plus 4, which is the 13. You can leave it like that, or going along the lines of writing it in 2 separate pieces. there is a plus bi. The last one down here, oh, actually, you know what? I'm going to skip number 9 for now. We'll come back to that later. The last one I want to do is number 10. That's a little more complicated. Don't let it freak you out. The rules are still the same. So in order to simplify this, I want you to realize that you are adding fractions together. So in order to add fractions, you need to make a common denominator. And the easiest way to do that is to multiply each of these fractions by the opposite denominator. And what's nice about these is those happen to be conjugates. So watch what happens when I do that. If I combine this fraction together right here, I end up with 4i minus 2i squared over 4 plus 2i minus 2i, so I'm not even going to write that down, minus i squared. Well, that, anytime you see an I squared, remember that's a negative 1. So if I rewrite that, I end up with 4i plus 2 over, what would that be, minus a negative 1, so over 5. This is an I, sorry, it looks sloppy. And then I need to do the same thing on the other side. I need to distribute this through. So that would be a 10 plus 5i. My denominator here is going to be the same. So I'm just going to go straight to the 5. So if I kind of carry that down, now I have two fractions that have the same denominator. And so remember how you work that out. To add fractions with a common denominator, you basically add the numerators and then put it over the common denominator. So I would end up having 4i plus 2 plus 10 plus 5i. If I combine my like terms, I get 12 plus 9i over 5, which you can leave it like that, or following along the rules of a plus bi, you get here. So either answer is fine. Thanks for watching. When I see you next, we'll kind of review this. Thanks.